It's really great to be in Berlin. Last time I was in Berlin, I had one of the more surreal moments of my life. It was the early hours of the morning. I'd been out drinking because I'm British and it's expected of me, and I don't want to disappoint anyone. And I was in one of the currywurst places, you know, waiting for currywurst. And this guy just burst into the shop, and he ran up to one of the people in the queue and just looked at him and shouted, "Your days in jazz are numbered!" And then he ran out the room. And I was like, holy crap, imagine being that guy who just found out that he was jazz mortal. You know, I was like, what would you do if you realized you only had a few days remaining of jazz in you? I guess you'd play a ton of jazz. I don't know. It's been playing on my mind ever since. Anyway, what am I going to talk about today? Right, progressive enhancement. Every couple of months, the whole progressive enhancement argument flares up, and battle lines are drawn, and on one side you get these dogmatic Luddites who think JavaScript should be banned from the web, and on the other side you get this group that thinks you need 2 megabytes of JavaScript just to render a paragraph, or at least that's how the debate plays out in 140 characters on Twitter, the home of reasonable debate. But who is right? I mean, there are benefits to making stuff work without JavaScript. There's loads of them. But I'm less convinced by particular arguments, such as, like, if your stuff works without JavaScript, it's like an escalator, in that when an escalator fails, it just becomes stairs. You know, the basics will still work. And that's great, but it is easier said than done. And it's fine if it's binary. You know, the JavaScript either happens or it doesn't happen. But if your JavaScript fails halfway through, the escalator is just as likely to catch fire and kill everyone on board. You know, and you know, you can prevent this if you know the particular breakpoints, but that's not always the case. Who here has to support Internet Explorer 8 as part of their job? IE8? There's a few hands. As a control study, raise your hand if you refuse blindly to take part in conference polling. Okay, yeah, that makes sense. To those of you who do need to support IE8, and it's great to see a kind of small number these days, when I need to support IE8, I make the core proposition of the site work without JavaScript, and then just don't give JavaScript to the older browsers. The BBC popularized this technique, and they called it cutting the mustard. So if a browser doesn't cut the mustard, it doesn't deserve your beautifully crafted JavaScript. And it's really simple to implement, just something like this. Before any of your JavaScript runs, perform a feature test, and if it doesn't pass, pull the ejector cord. And I mean, you could test features you actually use, and you should do that throughout your code. It's good defensive coding. But right at the start, I think it's okay to cheat a little, like I've done here, and sort of sniff out a modern-looking browser. Here I'm using the page visibility API, which I found by reverse engineering the data source for can I use, because it's the one API that doesn't work IE9 and below, and it doesn't work in the old Android WebKit browser. Although these squares are green here, they require the WebKit prefix, so you just don't test for the prefix. So when you block these browsers from running your JavaScript, they're just running off plain HTML and CSS. You're protecting yourself from the real bitey parts of these browsers. But the content still works. Developing becomes way easier. Testing becomes way easier. I mean, OK, maybe these horrible browsers could have run your JavaScript and you know, not thrown any errors, but they're not going to be fast at it. They're going to create a bad user experience. So when you do this with the newer browsers, you know, the world's kind of open to you. You can have fun with modern JavaScript and DOM features. I mean, I've used Internet Explorer as a bad example here. But I want to stress that I'm talking about the old versions of IE. Because Internet Explorer used to be a real dick to developers. But the newer versions, and Edge, their new browser, they're great. You know, that team are doing pretty amazing things. So don't confuse the old IE with the new stuff. There is an easy way to remember. Internet Explorer is a dick to developers if the version number is less than or equal to 8. That's a nice, easy way to visualize it. But if you don't need to support these old browsers, this approach, I think, can feel a little bit irrelevant, maybe, sort of like you know, progressive enhancement QUIRKSMODE, a sort of older way of doing it. Because if you can rely on the JavaScript engine in the browsers you need to support, I think you can depend on JavaScript. There's no reason for your stuff to work without it. And I think some progressive enhancement thinkers sort of disagree with me on this one. But if you spend more time catering for users that have JavaScript deliberately turned off than users who have to use assistive technologies such as screen readers, your priorities are all wrong. And I bring up accessibility deliberately because there's this fallacy that a JavaScript requirement makes something inaccessible, but it's not. You can actually use JavaScript to improve the experience in assistive technologies. Progressive enhancement is about finding a baseline and building up from it, and each project will have a different baseline. And it's not just browser capability, it's user capability in terms of cognitive, sensory, motor skills. It's about the device form factor, the inputs and connectivity. And we set and adjust these baselines in terms of our users. And we should be as inclusive as possible, but depending on JavaScript doesn't mean you necessarily exclude users. Of course, don't use JavaScript to do things the browser already does, like checkboxes and scrolling, especially not scrolling. Build on top of what's there. Use JavaScript to create great user experience. Things like Talkie.io, this is a WebRTC video chat app. Can't do that without JavaScript. SVG.OMG, it's an SVG minifier. Does its work entirely on the client. Of course, you could just replace this with a file upload form that sends the SVG to the server and it returns the result. And then you could enhance the client-side processing as part of that. But then the non-JavaScript version is a complete branch of the code. And it's not particularly useful compared to the command line version of SVGO. With progressive enhancement, every phase of the enhancement absolutely must have a real user that benefits from it, one that you can identify. And in a world where everyone has modern browsers, is progressive enhancement dead? So earlier in the year, I bought myself a PS4. And a particular feature of the PS4 sort of caught my eye. When downloading a game, you could play level 1, even though level 30 was still downloading. Well, whoopee shit. The web has had this feature for 20 years. This is the full HTML spec loading here over a throttled connection. It's a 3 megabyte document. It's still downloading, but it gets on screen after only 20K has downloaded. It's still downloading now. This is what makes the web feel fast. Browsers embrace data streaming. You don't need a lengthy install step to get somewhere. Whereas for things like the consoles, PS4, the web is a kind of awkward add-on. They're still figuring out what to do with it, because it was mostly just added in there for online gaming. And I am not interested in online gaming at all, because I've never played a game that I thought would be better with the addition of verbal abuse from a child. I mean, any game with the sort of headset thing going on, it's like being on the phone to the Westboro Baptist Children's Choir. I can't deal with it at all. But what do we do with this amazing web feature? We web engineer it away using this kind of all-or-nothing mentality. Performance matters. I mean, it actually really matters. Auto anything, they cut the page load time in half, 15% jump in revenue. The Obama campaign, 60% speed up, 14% increase in donation conversions. Walmart, every 100 millisecond they knocked off the time, grew incremental revenue by 1%. The Firefox download page, 2.2-second reduction, 15% increase in download conversions. And when I tell people these stories, the counter-argument is often, well, actually, this is an app, not a site. There is no definition for what a web app is and how it differs from a site. But all too often, web app is used to excuse poor performance, poor accessibility, just bad user experiences. And I mean, to put it simply, users do not stare at a blank loading screen and think, well, thank Christ this is a web app and not a website. Otherwise, I'd be really annoyed right now. And on that note, I do want to take a closer look at Talkie.io. This is the WebRTC chat app, demoed here rather not so great because we were in the same room, but I needed to make the video. The author of this website is a huge fan of frameworks, or at least he was, and he gave this really good anti-progressive enhancement talk in Brighton last year, and it was, he was eloquent and smart and clever, and I really, really hate him for that. So I'm going to pick on his site as a kind of petty form of revenge. I mean, He's actually changed his position on a lot of the stuff that I'm going to talk about. He's kind of agrees with me on a lot of this stuff, and that will be reflected in the next version of this. And I got his permission to kind of call out some of these things, so it's not too nasty. Anyway, we're going to have a look at how long it takes to render, and I'm going to use web page test, which is a wonderful resource. I'm just going to put the URL in there, and I'm going to select the connectivity. Well, I'm going to say I want to test Chrome, and I'm going to select the connectivity as 3G. 3G is the best connection type to test on because although some of your users will have like a fiber connection directly in the back of their head, many will have something much slower. A lot of us, well, pretty much everyone has a mobile phone. And although we have 4G now, even 4G-capable users will be on 3G or worse. About half the time in Germany, it's about half the time in the UK as well. It kind of differs from country to country, but it's, a lot of the time, even users that have the capability of these fast connections are not getting them. So we run the test, and eventually we get results back. And you get two results. You get the you get the first visit and the second visit. So the second visit will make use of caching and things. The empty cache version at the top there, that's the most interesting one, because we can't rely on the HTTP cache. Stuff falls out of it all the time, just gets pushed out by the browser. But also as developers, we're encouraged to ship often, so we are constantly invalidating the cache. We're changing our JavaScript every day, so if you haven't visited the site within 24 hours, you're going to have to re-download that JavaScript because it's changed. So one of the most useful bits is this film strip view that shows you screenshots of the site as it's downloading. And we can see here that the talkie takes 8 seconds to get to a first meaningful render. It's 8 seconds of blank screen. But let's put this into perspective. This isn't the worst. While the PS4 might be embracing progressiveness and streaming, the PlayStation Store has not. It takes a massive 16 seconds to get a meaningful render on the screen on 3G. And the PlayStation Store is a site as much as Amazon is, right? It's where you go to buy things, so 16 seconds is clearly ridiculous. But Talkie is a web app. Is 8 seconds all of a sudden worth it? When we think about page performance, we must consider what we got in the time we waited for it. And we didn't get a slick, featureful video chat app. We got that. All of the fancy stuff is an interaction away. Adobe spent a lot of time optimizing the load time of Photoshop, because really it was absolutely ridiculous to stare at this for 30 seconds to get this. Because what can I actually do with this? There are a load of buttons that don't do anything. There are stacks of menu items that are disabled. All I can do here is create a new image or open an existing image. Two things. That shouldn't require all that upfront loading. 8 seconds. It's alarming to me that this decade's web apps are willfully making the mistakes of last decade's native apps. We need to let users play level 1 as soon as level 1 is downloaded. And when downloading and displaying content, we don't want to wait until we've buffered everything before showing anything. So how could Talkie.io fix this? What could they do? The source code of Talkie is shaped like this, which a lot of the web has this model. There's no content in the markup. Don't do that. Put some content in. An empty body tag is a real missed opportunity. So some actual content. But what content could we actually put in there? Well, that. Whatever's needed to make that look like that. We have been doing that without JavaScript for a long time. If you're a content-rich site, such as Twitter, for example, is it a site? Is it an app? No one knows. The markup should contain what's needed for that, or at the very least, the main column with the tweets in it. Steve was talking about this yesterday. The time to first tweet. That's the most important content. And they did this. They switched from a JavaScript render to a server render, actually delivering markup, and their render time dropped to 1/5 of what it was. 1/5. If you absolutely cannot get content in your markup, then at least use markup for the rest of your UI, like the basic sort of structure of the page. But hear this. A splash screen is not an acceptable first render. It is an admission of failure. It is a gravestone commemorating the death of your performance. And don't put the names of those responsible on it. That's embarrassing. Same goes for spinners and loading bars. These are kind of failure cases. We're just sort of admitting that we haven't done things in time. Here's an example a little closer to home. This is Gmail, obviously. It has a loading bar. It takes so long to load that they actually offer you a basic HTML view. They are having to maintain 2 versions of Gmail because of this. But what do I get after the loading bar completes? Do I get an HD movie? Do I get an immersive WebGL experience? No. I get a list containing some text. I realized Gmail is really complex, and it was a game-changing web app, especially when it was first launched. But this is classic waiting for level 30 before you can play level 1. Anyway, what's next? Well, unblock your scripts. Scripts will block the render of subsequent content by default. And if you have scripts that are blocking your content, Steve Zauders will climb out of your TV and punch you in the face because he really hates this. You're not optimizing your site properly. That's kind of how he talks, I think. I don't know. So you can either move the scripts sort of after the content, or you can mark them up with something like async, and that makes them just download in the background and execute when they're ready. Alternatively, you could use defer, which has a slightly different behavior. It waits until the DOM is ready before it executes. It'll download before that, but waits. It won't execute until the whole DOM is there. And it preserves execution order of scripts as well, which is kind of handy. And interestingly, that feature started its life in Internet Explorer 4 back in 1997. Unfortunately, the implementation had a bug, which can cause one script to start executing midway through another script, and that just absolutely breaks everything. Unfortunately, this bug wasn't fixed, and it carried through into IE5 and IE 5.5 and IE6 and also IE7 and IE8 and IE9. They did fix it in 10, though. It is fixed there. But if you need to support IE9 and below, then I would definitely stick with async. It's the safer option. Loading scripts async and having actual content in the markup presents a small problem, because this first render includes this "Let's Go" button. The user can type the name of the chat room, the video call they want to start, and they can click that button. But that means that button could be there before the script that handles it has loaded and executed. I mean, we could hide it until the script is there, or we could put a spinner there. Nah, just lie to the user. Go full Volkswagen on them. Fake it. Pretend you're ready. Because you'll probably get away with it. This is the cool thing. But don't leave it to chance. You can have a little bit of JavaScript that, you've got this variable that your JavaScript will set to true when it arrives. So, this will tell you if the main JavaScript is downloaded and executed. Get hold of that form that contains the room selector, and if that form is submitted, if the main JavaScript is downloaded, whatever, they'll handle it. Otherwise, make a note of what room they wanted to create. And then, just wait for the main JavaScript to come in, and it can pick up that variable and go, oh, someone's already interacted with the page. I'll just start that call right now. I wouldn't actually even show a spinner at this point. Because the user has interacted, you react to that button being clicked straight away, change its color, give it a ripple effect or something. And because you've acknowledged the user doing something, you've actually got probably about a whole second before you need to kind of admit that you weren't really ready and stuff is still downloading. But that makes the spinner a kind of total failure case, trying not to show it if at all possible. With SVG-OMG, I'm actually really lazy with this. If you try and interact with the page anywhere before it's ready, this happens. I didn't put a lot of effort into it at all. And this may as well be, this. I'm super lazy about it. I could do something better, but the JavaScript needed to avoid this is only 15K, so I'm kind of betting that no one will ever see it. Well, I'm not betting. I'm using analytics to check as well. And it's happened 4 times. 2 of them were me testing the analytics were working. They were. And one of them was an old version of IE I don't care about. The other one appears to be genuine. But, that's 1 out of thousands. And I don't know, if there's a horrible UI in the forests and there's no user there to experience it. Is it a bad user experience? I'm going to say no as a good excuse. So if Talkie put content in their markup and they unblocked their scripts, how quickly would they get to first render over 3G? It was 8 seconds before, and it is now. Eight seconds. Something has gone wrong. We haven't fixed the main problem. Something else is breaking things. Actually, I want to have a go on the piano. This is nothing to do with the rest of the talk. I've just been dying to do this since I got here. I can only play one thing on the piano, and it's a piece of music that is featured in every episode of the X-Files. We've all seen the X-Files, right? Right, it's in every episode. Imagine the scene, okay. Did you guys just hear something at the window? Yeah, I'm going to go check it out. And then the person sort of pulls back the curtain slowly, and there's nothing there. And then there's an alien. I have been kicked out of about 12 music lessons for doing that, but okay, what were we talking about? All right, 8 seconds. Something is still failing. We thought we fixed problems, but we have not. Let's have a look at the network waterfall here. So, the script was blocking things for 2 seconds, and we fixed it, but it wasn't the main problem. This is the CSS for the font. Because it's to a different origin, you know, it has to go through this whole sort of DNS connection and SSL negotiation, all the kind of fundamentals of building up a connection. And that's the kind of shorter bit of the block that you see there. And when the server responds, it just serves with a redirect to say, yeah, it's not here, it's actually somewhere else. And the somewhere else is another origin. So you have to go through another connection setup, you know, the DNS, the SSL. 2 seconds is wasted just on that redirect. You know, we haven't actually got anything yet. And then the CSS delivers 200K of unzipped inline fonts. And that's never the answer. And this isn't Talkie's fault. This is their font provider's fault. And they're doing it deliberately. Why would a font company deliberately give a worse experience to their, you know, just regular users, regular innocent users, just like you? I mean, it's not like you would steal a car, is it? Or a handbag, or even a TV. Yeah, this user experience is brought to you by the letters DR and M. This is something they're doing to try and prevent people pirating the font, and that's what's adding an extra 4 seconds onto the render. Does it stop people pirating fonts? Of course it fucking doesn't, but you know, it makes them feel better about it, but it just gives everyone else a slower experience. So, we need to work around this. These DRM-style hacks are a real performance disaster, but even regular web fonts aren't particularly good for performance. They're real trouble, especially when they're used on body content of the page. Because hiding text until the font is loaded, that's bad, you know, because the phone has content that it can't show you. Showing a fallback is great, but then switching the fallback for the real font, I don't know, maybe it's just me, but I hate that. It's a really bad experience, especially if it causes the text to, you know, shift left or right by some amount, or worse, if it shifts vertically by a line. I find that to be a really disruptive experience. A new specification aims to improve things here, and this is the font rendering controls module level 1. But it adds one property to CSS, and it lets you specify what do you want for that font. Do you want it to, you know, block rendering for that text, or do you want it to go straight to a fallback and then switch? Do you want some kind of delay on it? The most interesting option, though, is this, font display optional. This means use the font if it's cached. Otherwise, download it, but don't use it on this page, but cache it for next time. So that means you get this really quick render with a fallback font. And it doesn't swap, it doesn't give that disruptive experience, but next time the user loads the page, they'll get the web font straight away. They don't get that delay. This was inspired by The Guardian, who were doing hacks with local storage to do this kind of behavior, and we want to make it, you know, faster to do that thing. This is still being implemented in Chrome. Hopefully it'll land next year, because, you know, the other browsers are into it as well. Anyway, in the meantime, we want to load these style sheets asynchronously, because I want to bring that font in for the other bits of the UI that aren't there yet, like the actual call screen, but I don't want to use a web font for that first render because it's just too disruptive for performance. So to load these style sheets async, I'm going to use this script. This is load CSS by the filament group. Unfortunately, we don't just have an async attribute on the link tag. We probably should. Hopefully, we'll add that as well. But in the meantime, load CSS will do the trick. So we can inline that script on the page. That's it there, and we're loading this CSS for the font. So now we can render without the font, but the font will be there by the time the user comes around to sort of using other parts of the site. So if Talkie did that, they put content in a markup, made their script async, and made their stupid font CSS async, what would their render time be? From 8 seconds to much better. That's a 6.4 second saving on FreeG. We saved 2 seconds on unblocking the JavaScript and a whopping 4 seconds working around this dodgily served web font. That's pretty good for FreeG, 2.6 seconds. There's a lot of overhead in FreeG, so that's pretty fair. But I would consider these things to be the basics. And if something about the JavaScript framework you use prevents you doing this stuff, seriously drop it and get a better one, because it's out of date. It was born out of date. It's locking you into the mistakes of last decade's native apps. It's really great to see things like Ember's fast boot and React.js and Angular 2, these things that can render on the server and actually deliver markup. And once they deliver the markup, the JavaScript goes and recreates all of the content, which, I don't know, I don't like that so much. But at least it gets you that first render a lot quicker. Much more excited about things like Dust.js, which is a stream-driven template language. And I know it's something that the React folks are looking into as well. So rather than be all or nothing, Dust.js takes this streaming approach. So this is a Dust template, and it will just write out this header and the start div tag, because it's got that content already. But then it'll hit this template value for foo. And if foo is just a string, then it'll just output it straight away. But if it's a promise, a JavaScript promise, it'll wait for that to resolve before it will, output what the result is. And if these values are actual JavaScript streams, then it will pipe the stream to the response. So you'll get this gradual render, which makes things a whole bunch quicker. And yeah, React.js has a fork at the moment, I think, that they're looking at doing some kind of streaming render, and it improves things massively, especially if you have to make connections to third-party servers. Because that can take a long time, and you want to get your initial render out before you've even started doing that. But yeah, don't buffer everything before sending anything. Instead, flush early, flush often. I wanted to make a poo joke here, but I couldn't make it work. But I kept the slide in anyway, so you can make your own jokes for that one. Anyway, using all the stuff I mentioned so far, I was seeing SVG OMG rendering around 2.6 seconds, the same as Talkie.io with the fixes. But I wanted to see how close to native performance I could get with the web, especially on mobile. The only render blocking thing I had that was similar was the main CSS, the CSS for all the page styling. So I want to avoid doing that. I want to avoid downloading all of the CSS just to get on the screen. I want to just take level 1's CSS and download that and then load the rest asynchronously. So to fix this, I'm going to use load CSS to load in my, the massive bit of CSS. And then I'm just going to inline the basic styles needed for that first render. I mean, this is pretty easy to do on a low-content site, because there's not a lot there. But we're fighting for some changes to the HTML spec to make it easier for high-content sites too. What we want to see possible is that you would use the link rel style sheet element in the body. And use it just before the content that needs it. So you would have your CSS for the article just before the article, and then you would have the one for comments just before the comments, and then some more. And the idea is the browser would block the rendering of everything beneath that style sheet until it had loaded. And that means you can break your CSS up into small parts. Well, I say break it up. We tend to have it in separate files anyway, and we combine it into this one monstrous file. So it's basically, don't do that step, and you can have your separate CSS. So that the page can render as soon as it's got the article CSS. The comments will be blocked until the comment CSS arrives, and then the sidebar will load. And you get this nice block progressive rendering. It's really good. And this is really useful over HTTP2, which actually works faster if you've got lots of requests of smaller files rather than these big, huge, monstrous files. And one of the reasons we want this, and we think it's safe to do this, is that this is how Internet Explorer behaves today. The HTML spec doesn't make it clear. Internet Explorer does the right thing, I think. We are going to, and we as in Chrome, are going to do the same, and we're hoping to convince Firefox and Safari to do the same. In the meantime, load CSS is definitely the way to go. So, with that inlining of the CSS for that first render and loading the rest async, this took the load time from 2.6 seconds down to 1.7. And 70% of that is the DNS, the SSL, just the connection setup stuff, which is just slow over 3G. There's not a lot you can do about it. 5K of content is all that's needed to get to the first render, which shouldn't be a shock because, look at it. There's not a lot going on there. There's not a lot it can do. All the heavy interaction is all the heavy functionality is an interaction away. This is kind of like what we saw before with Talkie and Photoshop. Don't have to load all of the complicated stuff that the user can't actually use yet. But even then, we can optimize for first interaction. This is the network waterfall for SVG, OMG, and this is the initial bit of HTML, that 5K that comes down in 1.7 seconds, and that gets us the first render. But the page isn't interactive. That happens 3/4 of a second later when we get the 4K of additional CSS and the 15K of JavaScript. Now the user can play level 1, not just look at the opening screen. They can select an image to optimize. They can drag one into the browser or load the demo image. Then these free other scripts arrive. And these are the big, heavy scripts. They handle SVG parsing and minifying, gzipping, syntax highlighting for the code output. But the user doesn't care that these were loaded in the background. If the user manages to select an SVG before these scripts have downloaded, it's going to take a little bit longer for it to optimize the SVG, but they don't know it's waiting on loading to happen. They think, well, I've asked it to do a job, and it's doing a job. It's fine for me to wait maybe an extra second. In the 99% case, though, these scripts will have loaded by the time they can select a file, because they're spending time doing that. And sure, I'm loading some JavaScript to then load some JavaScript, and that's kind of slower in total than delivering all the JavaScript in one big lump. But one lump would increase the time to first interaction. And it's first render and first interaction that really matter. When I was a kid at school, they had someone come in and tell us about the dangers of smoking. And I went home full of this new information that I'd learned, and I related it all to my dad, who is a smoker. And I said, Dad, did you know that cigarettes contain, and I reeled off everything I knew, 100 cancers and damage to society, and you're destroying the world. And then I finished on the big fact that I'd learned that day. I said, did you know, every time you smoke a cigarette, you reduce your life by 10 minutes. And my dad thought for a moment, and he looked up at me and said, can it be this 10 minutes? And despite being a total smartass, he was right. He had a point. The time people hate wasting the most is right now. And adding a few hundred milliseconds onto the total load time is worth it if it decreases the time to first render and interaction, because the user doesn't notice the extra, because they've got something they can use right now. They're distracted by actual functionality while the rest of the functionality is loading. So using the stuff mentioned so far, you can make your sites and apps really fast on Wi-Fi, rendering under half a second, even on an empty cache. You can be really fast on 3G, so we're talking here 1.7 seconds is probably the best you can do with an empty cache. But there's one more extremely common connection type that we haven't catered for. And it's not offline, it's this. I call it Li-Fi. No matter what the resource is, when you're on Li-Fi, it's going to take minutes to request it, and it's still going to fail. I mean, offline is okay. At least it's honest, and it's quick. Can I have this? No. Okay, I'll do something else with my life. Li-Fi is like offline, except it trolls you by pretending to be online. I mean, I've used one bar as a kind of description of this, but I don't know, I get this a lot. And my phone says I have a full modern generation signal, but can I squeeze a byte down that connection? No, can I fuck? I can't get anything through it, and it's frustrating because I'm staring at this. I mean, when your connection's like this, it's like a one-legged dog. It thinks it can play fetch, but it can't. And you have to watch it dragging itself along the floor with its one good leg, and it's depressing and it's horrible. This is me being Li-Fi 2 in the pub only a couple of weeks ago. I mean, look how sad my face is, the white screen. I have been driven to drink. Thankfully, they cater for that. It's a pub. But we need to save users from this. Progressive enhancement needs to evolve. The majority of users now have a frequently auto-updating browser. Enhancing based on browser features is kind of not as difficult as it used to be. Varying network connectivity has always been a bigger issue. And as mobile usage increases around the world and like emerging markets as well, it's an even bigger issue. Offline first is progressive enhancement with the network. Once again, enhancement turns out to be the better option than graceful failure and degradation. Because if I go to the network and then fall back to an offline resource if the network connection fails, the Li-Fi users are still kind of left in limbo. And although the network is a natural place to fix a lot of this stuff, we haven't done anything about it yet, really, because it was near impossible. But that's no longer the case. We have this new technology, Service Worker, which landed in Chrome in late January, and it'll arrive in Firefox in the next couple of months. So from your page, you call that bit of JavaScript, and now you get a script that sits in the middle of you and the network. This worker is very similar to other JavaScript workers if you've used them before. If you're not familiar with JavaScript workers, they're kind of like an elephant with like 12 legs, and instead of an arsehole, it's got a zebra. I mean, it's not actually like that. I just wanted to say that so it might get used in the song. It might be too late in the talk. I think he's already working on it. No, it's just a worker. It runs in the background. It's fine. But you also get this programmable cache that you can add and remove things from whenever you want. Inside that JavaScript, you receive these events like install when the browser sees it for the first time, activate when it's ready to take over pages, and this is the interesting one, fetch. Whenever one of these pages is requested, that can be controlled by the service worker, and also whenever one of those pages makes a request. Like other browser events, you can prevent the default and do your own thing. In the case of SVG-OMG, I use the install event to go to the network and fetch everything that I need, the HTML, the CSS, the JavaScript, store them in the cache. And now when the page is loaded, when it's requested, I just go to, it becomes like controlled by the service worker, the request goes there, I get a fetch event, just pick the response out of the cache and send it back to the page. The service worker doesn't do any of this for me. I've decided this is what should happen, and I've coded it using JavaScript. And although I'm specifying everything, the code is relatively simple. It's not a lot of code. So it's just things like in the install event, hey, wait until I've created a cache called this, and put all of this stuff in it, please. I can even include things from another origin. And then on a fetch event, it's going to say, hey, like when one of these pages makes a request or whatever, look for a match in the cache, and if there isn't one, go to the network. I'm not going to deep dive on the code. I'm just showing that it's not a lot. It's pretty simple, but you get full control. And that takes the performance of SVG-OMG second visits from 1 to 2 seconds for first render down to it's as good as instant. And this is how fast it is on 3G. This is how fast it is offline. This is how fast it is on Li-Fi. The network no longer has any say in the performance of this first render. And the user didn't have to go to an app store and install and wait to get this experience. The install happened while they were using the site, while they had the full functionality. Of course, you can't just serve from the cache forever, because as developers, we update things, we fix bugs, we create new ones, and we don't want the user stuck on some old version. So this is our install code from before, and every time you visit the site, the browser will check the service worker for changes. So if we change our CSS, we need to change the service worker as well. So I'm going to change v1 there to v2, and that counts as a change. And now when the browser loads the page, it sees that change and starts up a new service worker as like the next version. And it runs alongside the old one, because the old one's still serving pages, and we don't want to disrupt the user. Because this new one needs to go to the network, it needs to pick up all the files it needs, including the changed bits. and then it puts them in the cache. And this is why the cache has a different name, because we don't want to overwrite the cache that's still being used by the user. We don't want to disrupt them at all until we're ready. Now it will wait at this point, and by default, it won't take over anything until all the pages using the old version close. And now there's nothing left to control. The old version isn't needed anymore. It becomes, well, becomes redundant and goes away. But that means that the new version can move in and take over and start controlling pages with all its new fancy features and stuff. And its first order of business is to get rid of the old caches that it doesn't need anymore. It's a slightly gnarly piece of code, but that's what it's doing, deleting any caches it doesn't expect to be there. Waiting for the old version to sort of stop being used, that's kind of playing it safe. But you can do other things. You can call skip waiting, which is basically saying, I want to move in straight away and take over, and I don't care, I'll deal with it. OK, you're now controlling pages that were loaded with some old version of the JavaScript and CSS, so you need to be aware of that and deal with that. And in terms of user experience, it's kind of up to you how you present that to the user, if at all. You get events, and you decide what to do. For instance, if the update lands before the user interacts with the page, what I do is I just refresh the page. It doesn't matter. I mean, we'll see that happen here. User goes to get a file, page refreshes, you barely notice it. They've now got all of the latest features. However, if the update is slower and the user interacts first, we can't just refresh. That's disruptive. But you could show some kind of like a message saying, hey, here's an update available just whenever it's convenient for you. And you can do more than that, because this stuff is just done in JavaScript. You can kind of invent your own sort of changelog. You could know, for instance, that this new version has a security update that the user absolutely must have. And maybe you would say, OK, it's actually sensible to refresh the page at that point. It's a disruptive user experience, but it solves the security problems quickly. If the update is really small to a feature that's not used a lot, maybe don't tell the user at all. Just let this update happen naturally. What we saw before was like a version update, like getting a new binary from the App Store, maybe, is the native equivalent. But some updates are dynamic and continual. Like, for example, a page could make a request, which the service worker will get from the cache and send it back. But then the service worker goes to the network and gets an update for that and puts it in the cache for next time. You might do this with avatars, because it's not a problem if the user's looking at an avatar that's one request too old. It doesn't really matter. Another pattern is that the page, and this is my favorite one, the page sends two requests, and the service worker will get one from the cache, send it back. The other one goes to the network, and that goes to both the page and the cache. And how you handle this double dose of data from the page is once again, it's up to you. As a kind of example of what you can do, I created this sort of little app that shows train pictures from Flickr. I commute every day. I had zero inspiration other than I was on a train. Here's how it loads. You hit the site, it loads straight away, everything from a cache, really quickly. But then it goes to the network, and it discovers new content, and it invites you to scroll to get new stuff. This is very similar to what native apps like Twitter do. And this works really well for streams of content. We really need to save people from these varying network conditions. Unfortunately, when I suggest this, I sometimes get this response. Oh, I don't need to do that. This is a website, not a web app. Even in sites, we should be operating offline first. People use a native app for the BBC News. This is a site. I mean, we can't argue that this is not a site. But people will use native app equivalents because they provide a better user experience. And network handling is a big part of that. And so the BBC could do smart things like they could know how old the news is, tell you, you're looking at content that was last fetched 2 hours ago. There's lots of user experience details that you can add here to make the offline first experience really good. Something like Wikipedia. This is the citiest site there is, and this is something I prototyped recently. So this is just a website added to the home screen, but the user can search for articles and go to them, and then there's a read offline button in the top corner. So the user could say, oh, I'm going on a flight, I'd like to read this article. And now, when the user has zero connectivity or Li-Fi, they can still go into the app and click the link to the article and get it all instantly. Even sites benefit from this stuff. Anyway, what if I click one of the links here to Shelley's Ferron article. If we do that, we're kind of back in this li-fi situation because we don't have that particular article cached. Because we can't cache the whole of Wikipedia, you know, there's too much of it. But we're actually working on a feature that lets you do something better, and this is something we're just kind of playing with in Chrome Dev at the moment. So we're back here, we click the link, but we realize that the user's having trouble here, and we show them a message saying, hey, this is looking a bit slow, or it's failed. How about we load this in the background for you? So the user taps the button, and we say, would you like us to be allowed to show you notifications? This makes sense. It's a good contextual time to ask for permission. And then I can put the phone in my pocket, go and do something else. And then at some point in the future, my phone will vibrate, and it will say, hey, that article is now available to you. And it was not a good message, was it? Like, I need to work on that. It makes it sound like she's at the door with an axe or something. But it's all, even though I now have nearly zero connectivity, it's all loading instantly because it was all cached in the background. And this is a low-level feature called background sync. And this is just a way to say, hey, could you let me do some background work either now or when the user has connectivity, if they don't already. And this is how you would do things like, you send a chat message, you press send, it appears on the UI, sending this, and allow it so the user can put their phone in their pocket and get on with their life and know that it will be sent sometime later on. This is a couple of months away from hitting stable, so we're kind of working on the full spec right now. But we can see from this that Service Worker gets you these interesting new features. Offline first gets you on screen in less than 150 milliseconds. And you can do this today in Chrome, which, depending on what you're building, might be the majority of your users. Or certainly a large portion. And in a couple of months, Firefox support lands as well. IE have said it's on their to-do list. Well, Edge have said it's on their to-do list. Apple, as usual, kind of work in secrecy. We don't really know what they're up to. They just kind of appear on stage every year at Safari Christmas, and they tell us what presents they're giving us. So it's not going to be in Safari until at least the next Safari Christmas, which will be October, unfortunately. But there is a way you can use it safely today. I don't know if you've heard of it. It's progressive enhancement. Service Worker has been built from the ground up to be progressive enhancement friendly. Even on browsers that don't support Service Worker, it's not going to be there when the user first visits. It really encourages you to use this progressive pattern. If you want Safari to support this stuff, use it, because then your stuff will be faster in Chrome and Firefox than it is in Safari, and they're not going to stand for that. They're not going to be the slow browser. They'll deal with it. Also, working offline is just a side effect. In a lot of cases, the focus is performance. It's going to take a while for users to get used to a website that works offline. I don't know if you have on trains in Germany, we certainly have them in the UK, the bathrooms are these big sort of cylindrical things with big revolving doors, and when you get inside, you're greeted with this, the seashells or whatever. There's you get in and you have to press a button, and then you press the flashing L to lock it. And they also have Braille as well, so even blind people know they have to wait for the flashing button. I don't trust this. I don't trust this system because it has failed on me. And I was sat on the toilet and revealed to the rest of the carriage like a bad game show prize. It was probably my fault. I probably didn't hit the buttons in the right order or correct or something. But I prefer doors that I can lock, and I can check that they are locked. And this is the problem we have with offline. Users have had it fail on them so often, and it's difficult. If you say, this works offline, it's difficult for them to check that it's going to do that. But we are looking to change the mentality here. If you've got a manifest, a W3 manifest on your site, and the user visits a couple of times, we'll start saying, hey, do you want to add it to your home screen? Looks like you like this place. And when the user taps on that, it goes on their home screen. It now looks and performs and behaves the same as a native app. So the user expectation is going to be greater. There might be the expectation there for it to work offline. But it has all the benefits of the web. The updates are lighter, and web apps are more secure. The web is more secure than native, and they're shareable across devices and operating systems. So that is my challenge to you all. Render without JavaScript. Add in the level 1 behaviors early. And for future visits, render without the network. Save users from li-fi. This is how we beat native apps at user experience. Thank you very much.